So now that we've gone through an introduction, let's actually do a hypothesis test or go through the language of how we set one up and get just through the first steps of it. So there are 5 steps to a hypothesis test, right? First, we got to have some claim about the world, and then we turn those claims into our hypothesis test language, right? And I'll show you a couple examples that I've posted on Canvas. But it starts with these 5 steps. Define the parameters and hypothesis, right? Define what they are. Name the test. What test are we going to be doing? So we're going to be doing a test of means or a test of proportions. And we'll talk about that. Of course, we always have the requirements. We can't conduct these processes or techniques unless these conditions are met. We're going to calculate the test statistic from the given sample data, and then we calculate a p-value, which tells us the probability, right, of us observing that statistic under that given claim. And so if that's a low chance of observing that statistic under the claim, we then make an interpretation, right, a conclusion of what we believe about the claim. And so this starts with writing what we call formally a null hypothesis and an alternative hypothesis. You will see what that looks like. Let me show you what that looks like, and then we'll come back to this language here. So for example, as one of the Canvas pages I have posted in this section, you will see there are 6 different ways that we're going to write a hypothesis. Right, your null hypothesis is the H0, HA is the alternative. And so think about it like the complementary events. We either have this or this, right? You have a claim about the world, and it's either that or it's not, right? It's one or the other. And so you write a null and alternative hypothesis. We translate it into a mathematical statement like this. Right, and then we the null hypothesis, and then we write its complement. And so in these cases, notice there's always an equal sign within that context. Here's one specific example. A school publicizes the proportion of its students who are involved in at least one extracurricular activity is 61%. So our null hypothesis is the proportion equals 0.61. The alternative is that it doesn't equal 61. A car dealership announces the mean time for an oil change is less than 15 minutes. And so we have the mean is less than 15, the null hypothesis. Null means no effect, nothing, no change, right? And so null hypothesis always contain an equals, and then inequality symbol would be in the alternative, regardless of what the claims are. This is how we write them. Okay, we'll come back to look at some of those, or you can come and look and see how they were written there. Now, that's what we're talking about here as we do the null hypothesis and alternative hypothesis right here. The alternative always has an inequality symbol. The null hypothesis always has equals in it. And then we're going to decide, we name these tests, right, depending upon if it's less than or greater than simple, then we're looking at a one-sided test, a one-sided hypothesis test, right? We're only showing that the true proportion or mean is greater than or less than, versus a two-sided test. We're only interested in showing the true proportion or mean is different than the null. Okay, it can different meaning that it either can be greater than or less than. So it's our two-sided test. When we write the hypothesis, we're always using parameter notation within the context of that. If you look carefully, mu's and p's, okay, always a parameter. And we also do standard deviations, but we don't emphasize that in this class here. And then the alternative, right, we're interested in only one direction, greater and less than, or just showing a difference exists. And so then that would be the not equal symbol. That's what we're looking at. Here's an example here we can look at. There's actually 2 I can get on the screen here. The notation we're using is null hypothesis and alternative. Sometimes you'll see H1. So if you're looking at other resources, you'll see H1 as the alternative hypothesis. So in this case here, in order to win an election, you need to get more than 50% of the vote. Okay, a sample of the voters was polled to see if you are likely to win. And so your null hypothesis, right? We're trying to see if we're likely to win. So that's a p is greater than 0.50. That's always in the alternative, right? and then the null is p equals 0.50. And again, remember these are complementary events, right? One or the other. And then we use sample data, right? A sample of voters was pulled to check to see where we are with respect to the null hypothesis. And then this other example here, you can see someone says they're an 85% free throw shooter. To prove it, he shoots 50 shots and makes 37, giving him 74%. Right? What are the hypotheses? Again, the sample data is what we will use to test his claim that his proportion is 85%, right? And so statistically, we're trying to see how likely this would occur. What is the chance, what's the probability that he would shoot 37 out of 50 if, right, he's really an 85% shooter. So that's our introduction to hypothesis testing, or writing the null and alternative.